linear rules. So we'll start by looking at the general linear equation, which is shown by y equals mx plus c. So looking at the individual elements of the general equation, we know that c is our y-intercept. We know that m is our gradient. And what we don't always know is our y and our x. Now we know that these are called variables, and the reason being is that the values of those can change. They're not fixed like the gradient is or the y-intercept is. So what that means is if I put x equals 2 into our equation, I will find its corresponding y value. If I put x is equal to -10, I will find my corresponding y value as well, given that the gradient and the y-intercept are the same for the same equation. So now let's look at the first example here, which is asking us to determine the rule whose gradient is -4 and the y-intercept is 6. So first thing you should be looking at is the fact that the gradient is -4, which means that m is actually negative. Okay, so remember, we can absolutely have negative gradients, and all that means is that our graph is going in, the slope is going in a negative direction. And then we're told that the y-intercept is 6. Looking back at our breakdown of the general equation, we know that the y-intercept is represented by c. So substituting these now into our general equation, we get y equals -4x plus 6. And what we've done is we've ticked off the fact that the gradient is -4 and our y-intercept is 6. Now what I've done is I've included an image here I'll just make it a little bit bigger, on the right hand side as a reference point to the equation that we've just found. So what we can see here is that the graph intersects the axes when y is equal to 6. All right, and our gradient is going in a negative direction, which is shown by the graph in itself. Now, you won't always be given a graph when you're asked to find the rule. I've purely included it as a point of reference just to visualize what we've worked out. Negative direction. So, moving on to another example. So we're asked to determine the rule of a straight line that goes through the point 2, -3. So remember, that's when x is -2 and y is -3 and has a gradient of 3. Now this is a much more difficult example, however not impossible. So first things first, let's identify what's important in this equation. We're asked to find the rule of a straight line. So we should be thinking immediately y equals mx plus c. We're given a set of coordinates, so we know our variables. We know that when x is 2, y will be -3 for this particular line. And we're also told it has a gradient of 3. So we know that m is positive and it's 3. So let's substitute what we know first and then work our way to finding our y-intercept. So I'll write step 1, substitute the general equation, which is be y equals 3x plus c. So now, because we don't know our y-intercept, so I'm going to write to find our y-intercept, the coordinate into our answer we found in part 1. So what that will mean is that we're actually going to have where y is, we're going to replace it with -3, because remember in our coordinate y is -3, and that equals to 3 times 2 plus c. So now what we're going to do is essentially we're going to solve for c. So we're going to have negative 3 equals 6 plus c. Taking 6 to the other side becomes minus 3 minus 6 equals c, which gives me c is equal to negative 9. Now, putting it all together, so I'm going to write rewriting apologize for that, will be y equals 3x minus 9. Now, it's really important that you don't do all this work and not rewrite the equation based on the elements that you've found. So it'd be fine for you to do part 1, do part 2, but if you don't rewrite the equation with the new values, that being m and c, which is what we solved for, technically you're not answering the question. So make sure to take the time to go back over the actual question itself and see whether or not you've answered it. So what you can see here from example 2 is that we were able to find the rule of a straight line based on one coordinate and a gradient being given.